Hello fellow game makers, and welcome to part 3 of the Ribbon project, where we are going to take the theory from part 1 about creating custom geometry and from part 2 about the basics of textures in GameMaker into practice. We're going to add some animations, some interactivity. Here is what we are going to create. First, I'm going to show you how you can make the path points interactive so that the user can actually click on them and change the shape of the path during the game. As you can see, the texture updates accordingly. We're also going to have a look at how to animate this in various ways. Then I have this simple sphere, but it's not as simple as that, because when you move your mouse, you can see that it creates this nice trail effect. And we're going to have a look at how you can use the ribbon system to do that. And finally, this is just a small example I came up with. We have this little electrical field, and once you get close to it, it actually jumps to you and sticks to you like a little magnet while you move through it. Let's, however, start with this first part where you can drag these markers and they will update the path. I've already prepared the code for that, so let's have a look at it. First of all, what do you already know? You know these lines up here where we define the width of the ribbon, the step size with which we want to step through the path, the texture assignment, and the number of texture repeats. This is new, we'll talk about those later, but first I want to talk about this code block here. Because whenever you want to change the path points at runtime, it is a good idea to save them in the beginning, save the original layout of the path, so that you could snap back to the original path whenever you want. So what I do here is I have the variable I that counts from 0 through all the points in the path. The name of this method is a little bit strange, pathGetNumber, but what it returns is the number of points in the path. So we run through them, and for every point at position I, we save the x coordinate of that point and the y coordinate of that point into a little array that stores the x and y coordinates of those points, so we can come back to them later. In addition to that, I also create a new instance of this marker object, the little blue pin here. I call it object anchor, and we create that at the current x and y coordinates at position I. Also, I add a variable to this newly created instance. I call it point, and I feed it the current point so that the instance knows which point of the path it actually belongs to. So let's have a look at the code in the anchor object. This is basically a very simple drag and drop system. So in the beginning we have a variable drag set to false. Whenever I click with the left mouse button on the instance, we set that to true, and whenever I release the left mouse button, it's set back to false. Important here is the step event. So once the drag variable is true, we change the x and y position of the marker to the current mouse coordinates so that it will follow the mouse while it's being dragged. And this is the line that actually changes the path. Path change point can change the coordinates of a point of an existing path. What you have to do is you have to feed it the path resource. You have to tell it which point you want to modify. They start at 0 and count all the way up. And then we change that to the current mouse coordinates. The last parameter here is the path speed, but since no instances follow this path, it doesn't really matter. I always set it to 100. And remember, when we created the instance, we also created the variable point so that the anchor knows which point in the path it belongs to. Now we use this variable to tell the method path change point which point it should change. And the end result looks like this. You can click on one of the markers and it will move around and will take the corresponding path point along with it. Let's now have a look at how you can animate the texture here. Back in the ribbon object, in the create event, you can see that I also now have a variable for the image speed, which increases the image index of the sprite, and one that's called anim speed that I've created. We'll talk about that in a moment. Let's start with image speed. You know that image speed increases the image index of the sprite. So let's say I want to increase that by 0.5 every step. What I now have to do is I have to make sure that the texture resource gets updated accordingly, because right now it's only ever created once at the beginning, but in this case we want to update it every step. So let's go in the step event and add a new line here. Ignore what's already written, but let's just update the texture resource and get the current image index of the water sprite. And again, this image index is automatically increased by the variable image speed that we've set to 0.5. Nothing else has to be changed, and you can see that now the sub-images of that sprite create this little animation. An alternative way to animate this water would be to not use the image index of the sprite, but actually move the sprite along the path. And that's what I do here. I have created a variable anim, and whatever the value of anim speed is, that gets added to the variable anim once every step. So let's set anim speed to 0.1, and let's now have a look what this variable anim actually does. We go in the draw event, and you can see that this is all the same code that you know from part 1 and 2. The only thing I've changed is here when we draw the vertices to the U texture coordinate, so the X position of the texture, I add this offset. I add the current value of the anim variable. And this offset increases because 0.1 is added to it every step. That means that the U coordinate shifts towards the right, and that's enough to create an animation. As you can see, the texture itself doesn't animate right now. It only moves towards the right because we add the offset to the texture coordinate. If you want, you can combine both effects. In this case, it doesn't really look that spectacular, but let's just also switch the animation of the sprite back on, and you can see the combined effect. Looks like this. I mean, you can play around with the values, with the variables, decrease the number of texture repeats. That's also a good idea if you want a nice flowing water effect. Let's switch the animation back off and set these two values to 0. What I want to show you is in the step event this other code that I've created, wiggle path points. Let's activate that. What we have is a variable called update, and that gets increased once every step, and whenever it hits 4 it gets reset to 0 and this code is run. I don't want to run it every step because the wiggling would be too crazy, so here it's only wiggled once every 4 steps. How does the wiggling work? Well, again, we have the variable I that counts from 0 through all of the path points, and for each path points it creates a vector. Think back to part 1 when we talked about vectors. They have a length and a direction. The length here I set to a random number between 0 and 50, and the direction I set to a random number between 0 and 360, so any direction is possible. Now I change the current point I that runs from 0 through all of the points in the path to the original position of that path point plus the vector with the length L and the direction D that I've created before. It's important that you always add this as a starting point, your saved coordinates. Otherwise the wiggling would continue where the last step left off, and that could mean that your path loses its shape completely and perhaps even moves off the screen. So you always have to make sure that you use your base coordinates that you've saved and then add the wiggle vector. Let's see what that looks like. So the wiggling works, but with this texture, it looks very strange. So let's actually change that. I found this electricity texture. Let's have a look here. Let me remember the size, 128 by 64. And let's use that as a texture. So we'll go back to the variables. We change that to sprite electricity. I also want only 5 repetitions. Let's increase the image speed. Let's also set the step size to 0.1 here, so that the path isn't that accurate, but a little bit more rough. And also let's make sure that the image index of the electricity sprite is used to create a new texture every step. Now let's see what that looks like. Let's hide the anchor points. Well, as you can see, you have an electricity effect that looks quite decent. And you have the added bonus that you could even pick these path points and actually change them even though they are wiggled around, because we use the saved coordinates from the beginning to update the path points every step. Next, let's have a look at the trail effect here. As you can see in the top left corner, I count the number of points in the path, and you will see that once I move the mouse, the value increases up to a maximum of 10, and whenever I stop, it will decrease back to 0. The secret to this effect is the sprite that I use. As you can see, it's a triangle that fades off towards the left edge. The trick is that I only use this texture once along the whole path. So we set the texture repeats to 1. That means whatever the size of the path, this trail will be stretched all along the path. Let's have a look at the rest of the code. So in the beginning, we just hide the normal Windows mouse cursor. You don't have to do that. And I also create these buffer variables, which will be important in a moment, mouse X previous, mouse Y previous. Also, I create a new path resource, because obviously the path shape depends on how the user moves the mouse, so it makes no sense to have a pre-made path asset for that. So I create a path resource called trail. I set it to an open path by calling path set closed false. I also set it to a smooth path by calling path set kind 1. 0 would be linear and 1 is smooth. You know all of those items here. And finally, I set the texture repeats to 1. It's also important to remember that whenever you create resources at runtime, you should also make sure that they are freed from memory once the object is destroyed. So if the path still exists at the end of the lifetime of the object, I delete it. The draw event is absolutely unchanged, nothing new here. I only draw the circular new cursor sprite over the trail. And finally, let's have a look at the step event, and let's actually start at the end of the step event. After all of the calculations for this step have been done, I take the current mouse coordinates x and y and feed them into these buffer variables mouse x previous and mouse y previous. Because we're going to use those values from the previous step and the new current mouse coordinates to actually find out how far the user moved the mouse. And that happens here in this first part of the step event. So we calculate the distance between the previous mouse coordinates from the last step and the current mouse coordinates at this step. And if they are larger than 2, and you can play around with this threshold value, if they are larger than 2, then we're going to add a new point to the path at the current mouse coordinates. This makes sure that the path doesn't constantly update even though the user doesn't move the mouse. It also could change the threshold when the trail is created. So if you move the mouse slowly, it does not create a trail, and only if you move it far enough per step, it will actually create a trail. It's also important to make sure that the trail does not get too long. So whenever we add a new point, we also check whether the total number of points exceeds 10. If so, we delete point 0. And 0 is always the first point in the path. In this case, it's the oldest one. So we're going to delete the beginning of the trail. And also, if the user does not move the mouse, we also should make sure that the trail decreases and disappears. So if there are still points left in the trail, we also delete the oldest point, 0. And the result looks like this. The triangle gets stretched along the path. The path points are added at the current mouse coordinates, but only if I move the mouse. If I don't do anything, the trail just disappears. And finally, we had this little electrical field, and when you move through, it sticks to the player. This is just a combination of the effects that we've already talked about. Let's have a look at the code. Again, in the draw event, nothing changes. This is the draw event that you know from part 1 and 2. Also, the initialization here is the same as you already know. In this case also, we only use one texture repeat. We also animate the texture using the image speed variable. And it's important again to save the path points. Let's have a look at the path actually. That's what it looks like. It only consists of 3 points, 0, 1, and 2. And actually the one that we need is number 1, the one here in the middle. So we don't even need to save the other ones, but I didn't want to change the code, so we save all 3 path points, but we only need number 1. And now in the step event, we check whether the distance from this point in the middle of the path to the current X and Y position of the player is lower than 100. If it is, it means that the player is within the distance of the magnetic field of the path. And if it is, then we change the middle point, number 1, to the current X and Y position of the player. If it is not within those 100 pixels, we change the point back to its saved position from the beginning. And if you want, you can even add a little special effect here, some sparks, so that whenever you move through the electrical field, you make the sparks fly around. Now, I hope that these examples gave you some ideas for your own projects. You can find a download link in the description of this video where you can have a look at all the code and modify it however you want. Okay guys, this concludes the Ribbon project. I hope you had fun following along, and see you soon.